Hello everyone and welcome to eSIP9. So for today's video, I'm going to be discussing an introduction to hyperbola as well as its parts and orientation. But of course, before anything else, please don't forget to like and subscribe to eSIP9 so that you'll be notified with our new videos. Hopefully, at the end of this lesson, you will be able to define hyperbola and determine its orientation and parts. Now, to define a hyperbola, it is the set of all points in a plane such that the difference of the distances of each point of the set from the two fixed points is constant. And if you remember our introduction to conic sections, a hyperbola can be made if a plane intersects the double napped cone, such as this figure in our right side. In regards to orientation of a hyperbola, there are two basic orientation of a hyperbola, which is a horizontal hyperbola and a vertical hyperbola, and it is very dependent on the standard form of equation of the hyperbola. Now, if you can see here, we have two similar equations. Okay, you may think that it is the same, but if you look very closely, you can see that there is a positive and a negative variable right here. Now, if the positive variable is x, then we can say that our hyperbola is horizontal. But as you can notice here in a vertical hyperbola, in its equation, y is the positive variable. You can see here as well that this equation will always be equal to 1, and where a squared and b squared is constant in the denominator. So that is the difference between the horizontal and vertical hyperbola in regards to its standard form of equation. Again, in a horizontal hyperbola, x is positive, while in the vertical hyperbola, y is positive. Okay, so this is an example of a figure of a horizontal hyperbola, and here we have the figure of a vertical hyperbola. And reminder, here a squared is always below the positive term, while b squared will always be below the negative term. So the arrangement of a squared and b squared will not change regardless it is a horizontal or a vertical hyperbola. Now, for example, we have here equations of a hyperbola, and we are to determine its orientation. Now, as you can notice here, x is the positive term here, so we can say that this is an example of a horizontal hyperbola. And here, it is x again, which is the positive term. And again, this is another example of horizontal hyperbola. And then lastly, we can see here that y is the positive term, and therefore we can say that this is a vertical hyperbola. Now, if we are to ask, or we are to identify the a squared and the b squared, 6 here is our a squared, while our b squared is 9. Here we have an a squared of 10 and a b squared of 5. And right here we have an a squared of 25 and a b squared of 16. So this is just a short example of how we can identify a squared and b squared, and as well as the orientation. Now let us move on to determining or identifying the parts of a horizontal hyperbola. So we have here our center, and then after the center, we can identify the vertices. Now, the vertices will always have a units away from the center. And then next, we have the transverse axis, which is a line that always passes through the vertices and the center, and then later on the foci as well. We have here the co-vertices, and it will always be b units away from the center. And then along the co-vertices and the center, we have the conjugate axis. And then we have here the foci, which is always c units away from the center. And then if we are to connect the vertices and the co-vertices, we will form the fundamental rectangle, which can help us graph the asymptotes. And now when we have the asymptotes, we can graph the hyperbola itself. So this is an example of a horizontal hyperbola and its parts. Now we still have the same parts in a vertical hyperbola, but let us look closely on how it differs to a horizontal hyperbola. For a vertical hyperbola, we have here our center, and where the vertices are in top and at the bottom. Now it is always a units away. And then we have the co-vertices, where it is at the right and at the left of the center always. And then along here, we have the conjugate axis. And then the co-vertices will always be b units away from the center. And then we have the fundamental rectangle right here, and as well as the foci. And then, as usual, we have the asymptotes where we can graph using the fundamental rectangle. And then we can graph the hyperbola right here at the top and at the bottom. So this is an example of a vertical hyperbola. So let's start with the center. The center is the intersection of the transverse axis and the conjugate axis. Just like in the other conic sections, the center is always denoted by HK. And if you look closely in our standard form of equation right here, H will always be beside the X variable, while K will always be beside the Y variable. And if we are to get the center HK, we try to get the opposite sign of the following constants right here. So if we have negative K right here, then the Y coordinate in our center is K, as well as negative H will be H to get the center at HK. So to further understand this concept, let us try to identify the center of this given hyperbola. Now, we can see right here that negative 3 is beside the Y, and we have here negative 8 beside X. So therefore, our center is at positive 8, 3. This is our center. So this is how easy we can identify the center of a given hyperbola. Now the next after the center is to identify the vertex or the vertices. Now the vertex is a point of the hyperbola that intersects with the transverse axis, and its distant from the center is always A. So the first step in identifying a vertex is to identify its distance, which is A. A will always be get from A squared. Now, to determine A, we only need to get the square root of A squared. Now, before you determine the vertex, after figuring out the value of A, the orientation of the hyperbola is very important. Because, for example, in a horizontal hyperbola, we will add and subtract A in our x-coordinate. While in a vertical hyperbola, we will be adding and subtracting A by the y-coordinate. As you can notice here in our example, which this is a horizontal hyperbola, from the center, right here, we will be moving or we will be determining the vertex along the x-axis. So, it is on the right and as well as on the left. So that is why we add A and then we subtract A along the x-coordinate. Look here for example. So this is the previous example where we identified the center to be at 8, 3. In further analysis of this equation, we can notice that since y is the positive term right here, then we can say that this hyperbola is an example of a vertical hyperbola. Now, knowing that this is a vertical hyperbola such as this one, so I want to get a visual representation of a vertical hyperbola. Then, for example, we have the center right here. Then it would mean that the vertices will be on top and at the bottom. So, in this case, we are to add and subtract A along the y-coordinate. Knowing that, let us try to solve first for the A value. We know that A squared will always be right here, which is 55. Getting the square root of both sides, we can identify A as equal to the square root of 55, which is equal to 7.42. To get the first vertex, we have H, K plus A, which is equal to 8 over 3 plus 7.42. So our first vertex will be at 8, 10.42. So this is our first vertex. Now for the second one, instead of k plus a, we have k minus a. And then substituting the values, we have 3 minus 7.42. So therefore, we have 8, 4.42. So this is our second vertex. So this is the final answer. The vertices are at 8, 10.42 and 8, negative 4.42. So this is how we identify our vertices. So next one, let us try to identify the covertex. As for the covertex is a point of the fundamental rectangle for the asymptotes with the distance of b from the center. So if the vertex has an a distance from the center, a covertex will have a b unit away from the center. And it is very dependent as well in the orientation of our hyperbola. So for example, we have a horizontal hyperbola. We will be adding and subtracting b along the y coordinate. But if it is a vertical hyperbola, we will be adding and subtracting b along the x coordinate. Now looking upon here an example of a horizontal hyperbola, we can see here that from the center, the covertex is on top and at the bottom of our center, which implies that the covertices are along the y-axis, and therefore we will be adding and subtracting b along the y-coordinate. So that is an example of how we can identify a covertex along the horizontal hyperbola. So for example, we have here the previous example we had before. Okay, but now we are trying to find the covertices. Now the first step is to identify our b unit or our b value. So since we know that our b squared would be along the negative term or the denominator of the negative term, we have b squared as 13. Now solving for b, all we have to do is to get its square root. So we have the square root of 13, which is equal to 3.61. For example, we have the vertical hyperbola, such as right here. We can say that the covertex would be at the right and at the left of the center. So therefore, the covertex will be along the x coordinate. So it means that we'll be adding and subtracting b along the x coordinate or our x term, which is 8. So to get our first covertex, we know that h plus b comma k would be the right thing to do. So substituting the values, we have 8 plus 3.61 comma 3. And then simplifying the following numbers, we have 11.61 comma 3. So this is our first covertices. Now for the second one, instead of h plus b, we have h minus b comma k. We have 8 minus 3.61 comma 3. So our second covertex is equal to 4.39 comma 3. So these are our final covertices. We have 11.61 comma 3 and 4.39 comma 3. So let us try to identify the foci or the focus. So the foci are two fixed points at the hyperbola with a distance of c from the center. So this formula is very familiar for a lot of you because this is the same formula in identifying the c in our ellipse. So c is equal to the square root of a squared plus b squared. Now to determine our foci depending on the orientation of the hyperbola, in horizontal hyperbola, c will be added and subtracted in our x coordinate. while in a vertical hyperbola, c will be added and subtracted along the y-coordinate. So here in an example of a horizontal hyperbola, we can definitely see that the foci is at the right and at the left of our center. So therefore, it is along the x-axis. And therefore, we are to add and subtract c along the x-coordinate. So let us move on to our example, such as this one. Let us try to identify first our c. So we know that our a squared is 55 and our b squared is 13. Now to determine c, we know that it is simply the square root of a squared plus b squared. And knowing this one, we have 55 plus 13. So c is equal to 2 square root of 17 or 8.25. Okay, now that we know our value of c in a vertical hyperbola such as this one, so let us say that in estimation it looks like this, our foci will be along here at the opening of our hyperbola. Okay, so it means that from the center it is at top and at the bottom. So therefore, it is moving along the y-coordinate. So we definitely need to add and subtract c along our y-coordinate. So to determine our first focus, we have h, k plus c. So substituting the values, we have 8, 3 plus 8.25. So our first focus is at 8, 11.25. As for our second focus, instead of k plus c, we have k minus c. And then we have 8, 3 minus 8.25, which is equal to 8, negative 5.25. So in summary, our foci are at 8, 11.25 and at 8, negative 5.25. So these are our foci in this given hyperbola. Now, as for the asymptotes, these are the lines that the hyperbola continuously gets closer and closer but never intersect with the curve. So as you can see here in our figure, the lines that you can see here that intersect with our center are our asymptotes. And if you can see right here with the curves that we have in our hyperbola, it continuously goes closer with our lines right here, but it will never intersect them. So this is how we can determine the width of our hyperbola or its opening. So to determine the equation of these lines, we have the following equations. For a horizontal hyperbola, we have y minus k is equal to positive and negative b over a multiplied by the quantity of x minus h. And then for the vertical hyperbola, we have y minus k is equal to positive and negative a over b multiplied by the quantity of x minus h. So as you can notice, it is very similar. The only difference is the arrangement of the value of b and a here. For a horizontal, b is at the numerator, and at the vertical, a is at our numerator. And if you can notice right here as well, we have positive and negative versions of this equation as a equation of the two lines that we can see right here. So let us move on with our example right here. We know that this is an example of a vertical hyperbola. Knowing that this is a vertical hyperbola, we can say that we need to use the equations of y minus k is equal to positive and negative a over b times x minus h. So this is the equation that we would need to determine the asymptotes of a vertical hyperbola. So we have identified earlier as well the value of our a and our b. We know that a is equal to the square root of 55 or 7.42 while b is equal to the square root of 13 or 3.61. So knowing the center as well, we know that the center is at 8, 3, where 8 is our h and 3 is our k. Knowing the following values, we can determine our equation for our asymptotes. So we can just substitute the following values. We have y minus 3 is equal to positive 7.42 over 3.61 times x minus 8. Now, in simplifying this, we have y minus 3 is equal to 742 over 361 times x minus 8. So this is our first equation for our asymptote. As for the second one, we just need to get its negative version. So we have, instead of positive 742 over 361, we have y minus 3 is equal to negative 742 over 361 times x minus 8. So this is our second asymptote. So this is our final answer. So don't worry if you want to use an a and b value such as square root of 55 and square root of 13, because you will still get an estimation or the same estimation as our answer for today. Okay, let us move on with the other parts. We have what we call the transverse axis. So this is the axis that passes through the vertices and the foci, and it intersects the hyperbola itself. So as you can notice here, this is our transverse axis. As for a vertical hyperbola, it again intersects the focus, the vertex, and as well as our center. So this is the transverse axis. And next, we have the conjugate axis, which is the axis that contains the co-vertices. So we have here the conjugate axis. And as for the horizontal, we have it here. And then lastly, we have the fundamental rectangle, which helps in creating the asymptotes of the hyperbola from the opposite edges of the rectangle. So in creating the fundamental rectangle, we just need to connect the vertices and the co-vertices. So we have here the rectangle, as you can notice here. And in drawing our asymptotes, we just need to follow the corners of our rectangle to draw the following asymptotes. And right here, again, we have here the fundamental rectangle as well. And as you can notice here, as for the asymptotes, it is along the edges of our fundamental rectangle as well. So these are all of the parts of our hyperbola. Again, we have the center, the vertices, the co-vertices, the foci, and then we have the asymptotes, and the transverse axis, the conjugate axis, and then lastly, we have the fundamental rectangle. So all in all, these are all the parts that create our hyperbola. So I hope that you learned a lot from this episode of our video in Isip-Nayan, and I hope that you stay tuned with our next videos. Thank you for watching. This has been Isip-Nayan.